Welcome back, curious minds, to another deep dive here at Neural Intel. Today we're digging into some really fascinating source material that's been making waves, a detailed look at Kimi K2, Open Agentic Intelligence. As always, our mission is to unpack the core technical innovations and what they really mean for practical applications. We're focusing strictly on the tech, the capabilities, the advancements. We really want those aha moments for you, clarifying how this system works and why it matters from a purely technical perspective. And hey, if you want to stay updated on papers like this, check out our webpage, linked in the bio. Okay, so let's get into it. Kimi K2 is called an open agentic intelligence. What does that actually mean? How does it set itself apart from, other models we talk about? The agentic bit, that clearly points to its ability to act autonomously, right? Understand a goal, figure out the steps, use tools.
Exactly. It's about goal-directed behavior.
And open suggests maybe transparency in its methods or accessibility.
That seems to be the implication, yes.
Yeah.
Though the specifics of open can vary.
Right. And the source material kicks off with a pretty bold statement. All models evaluated above are non-thinking models. That sets a crucial technical context. It sounds like they're positioning Kimi K2 as pushing towards a different kind of capability, something more independent.
That's the framing. It's about moving along that spectrum. And what's fascinating is how they build this, drawing from insights in both pre-training and post-training. The source really highlights pre-training as this foundational layer for agentic intelligence. It establishes the sort of priors, the basic knowledge needed.
Okay.
And that makes the next stage, the reinforcement learning exploration, much more tractable, efficient, and importantly, generalizable.
Makes sense. Build the foundation first.
But they also flag a big challenge.
Yeah.
Human data. It's described as a finite fossil fuel. Its growth just isn't keeping pace with compute power. And this leads them to say that token efficiency during pre-training is a new critical coefficient in the AI scaling laws.
So getting more intelligence out of each piece of data is paramount now.
Precisely. Every token counts more than ever.
That's a really powerful point. So if that human pre-training data is becoming this bottleneck, where does the continued learning come from? How do these models get better beyond what we can feed them?
Well, that takes us straight into what the source calls the era of experience. They attribute this concept to David Silver and Richard Sutton, dating it around 2025. In this idea, the LLMs learn primarily from their own self-generated interactions.
Okay. Learning by doing, essentially.
Yes, exactly. They get rewards based on those interactions, which frees them from the limits of finite human data and potentially allows them to surpass human capabilities in certain areas.
That's a major conceptual shift.
It really is a different way to think about model evolution.
It's definitely an ambitious vision, models learning from their own experience, but the paper, as you said, kind of hints at the difficulties. What do you see as the biggest technical hurdles in actually making that work reliably, especially if it's mostly learning from itself?
Oh, it's definitely complex. One big one is error correction, right? If the model makes a mistake and learns from it without external guidance, how do you prevent it from reinforcing its own errors or biases?
Right. It could go down a wrong path.
Exactly. And another is ensuring the diversity of that self-generated experience.
Yeah.
You don't want the model just doing the same things over and over and getting stuck in a narrow rut. You need rich, varied interactions.
Good points. Okay, going back to that token efficiency you mentioned, they developed a specific tool for that, didn't they? The MuonClip optimizer. Why is that piece of tech so central to Kimi K2?
It is. So their previous optimizer called Moonlight was already quite good, better than the standard Atom W in terms of efficiency.
Okay.
But when they tried to scale Moonlight up, particularly with architectures like DeepSeek V3s, they hit a wall, training instability, specifically exploding attention logits.
Exploding attention logits. And can you unpack that a bit?
Sure. Think of attention logits as internal signals the model uses to decide which parts of the input are most important for the current task. If these signals get way too strong, like turning the volume way, way up,
The whole system goes haywire.
pretty much, training becomes erratic, unstable, can even crash. And this happened more with their efficient Muon optimizer than with Atom W. Existing fixes weren't quite cutting it.
So MuonClip is their solution. How does it work? What's the clever bit?
The clever bit is a technique they introduced called KeyClip. It's like a proactive governor on those attention signals. Instead of just reacting when things get out of hand, KeyClip directly rescales the weight matrices for the query and key projections, the things that generate the attention signals after each Muon update step.
So it controls the scale right at the source.
Exactly. It reins them in before they can explode. The paper gives the specific math, but conceptually, it's about maintaining stability during the update process itself. A subtle but powerful idea for large-scale training.
Okay, and the result? Did MuonClip deliver in practice during Kimi K2's training?
It seems so. They report pre-training Kimi K2 on a massive 15.5 trillion tokens using MuonClip. And the key metric, 0 training spikes.
0 spikes on that scale. That's
Yeah.
really significant.
It is. Training instability is a huge headache and cost factor in LLM development. MuonClip seems to provide remarkable robustness, and they suggest this Q-clip idea might be a general technique, potentially useful for other stabilization problems too.
Interesting. If it's general, where else could you see something like Q-clip being applied beyond just attention logits? What makes it broadly useful?
Well, its core function is controlling the scale of internal network activations, right? That's a common source of instability in many deep learning scenarios.
Okay.
So you could potentially adapt it to prevent exploding gradients in really deep networks, maybe stabilize training for certain types of generative models where outputs can sometimes become chaotic. Anywhere internal signals risk running wild, a mechanism like this might help.
Makes sense. Okay, so beyond the optimizer, the paper points to 2 other big technical pillars for Kimi K2's agentic side. Large-scale agentic data synthesis and general reinforcement learning. How do those fit in?
They're crucial for teaching the model how to act agentically. The data synthesis pipeline sounds quite sophisticated. It's inspired by AC Bench, apparently. It doesn't just collect data, it simulates real-world scenarios involving tool use at scale. We're talking hundreds of domains, thousands of tools, some real, using this MCP standard.
MCP Model Context Protocol.
Right. Think of it like a standard way for models to talk to external systems or data sources.
Got it.
So real MCP tools and also synthetic ones. It generates data from hundreds of different agents using various tool combinations. And crucially, all the tasks are evaluated using rubrics for consistency.
So it's a systematic way to generate tons of high-quality examples of how to use tools to solve problems.
Exactly. Scalable, diverse, high-quality agentic training data.
Okay, and the reinforcement learning part. It mentions handling both verifiable and non-verifiable rewards. That sounds tricky, especially the non-verifiable stuff. How do they tackle that technically?
Yeah, that's a classic RL challenge. For tasks where you can't easily check if the answer is right, like writing a good research report, they use a self-judging mechanism.
The model judges itself.
Essentially, yes. The model acts as its own critic, using those rubrics I mentioned to provide feedback on its own performance. It's a way to get scalable feedback without needing a human for every single step.
Interesting. Bootstrapping its own learning.
Kind of. And then for tasks where there are clear right-wrong answers, math problems, coding competitions, things with verifiable rewards that use on policy rollouts, the feedback from those tasks continuously updates and improves the internal critic.
So the verifiable tasks help refine the critic, which then gets better at judging the non-verifiable one.
Precisely. It's a clever loop to improve evaluation accuracy and guide learning, especially where human feedback is slow or costly.
Okay, so we have efficient training, loads of agentic data, smart reinforcement learning. What does this actually let Kimi K2 do in practice? The source suggests it can just understand a goal and use tools without complex setup. What are some examples?
Well, they give this example about exploring remote work salaries. Kimi K2 apparently uses 16 different IPython calls.
16. Wow.
To generate stats, make charts, and even build an interactive web page presenting the findings. And the description sounds impressive. Good design, responsive, even an interactive simulator built in.
That's more than just answering a question. That's synthesis and creation.
Totally. And it gets specific, finding things like a plus 8% salary premium for remote entry-level jobs, but a penalty for mid-level, and another premium for expert level. That level of detail, generated autonomously, is striking.
That is quite specific output. Another complex one they mention is the Stanford NLP genealogy task.
Right, what did it do there? It generated an interactive website for that too, but the process involved a whole sequence. 5 web searches, 4 times browsing pages, 3 clicks, 5 scrolls, 6 edits to something, and 2 deployments.
That really shows the orchestration, doesn't it? Planning and executing a multi-step process involving web interaction and content creation.
Exactly. It's managing a workflow.
And they also talk about using it directly on the command line. Like it edits your files, runs commands for you.
Yeah, it supposedly understands your local environment, figures out what commands or edits are needed for your goal, and just executes them. Again, orchestrating different tools, a shell, editors, etc.
Like a super-powered assistant right in your terminal.
That's the idea. And the examples get quite technical. Automating Minecraft development in JavaScript.
Seriously, Minecraft.
Yep. Managing the rendering loop, running tests, debugging, capturing logs, iterating on the code. Or another one, converting a whole web project from Flask, which is Python, to Rust.
Whoa, okay, that's complex. Refactoring code across languages, running benchmarks.
It implies a pretty deep understanding of code structure and execution. It's definitely way beyond simple Q&A.
These examples are really impressive, showing that agentic capability in action. But, with that much autonomy, what are the potential technical weak spots? Where might these agentic systems still stumble or require careful human oversight in the real world?
That's a crucial question. Even with these advances, handling very ambiguous or abstract instructions from humans can still be a challenge. It might require more back and forth, more clarification.
Okay, understanding intent is still hard.
Right. And generalizing to completely new tools or environments it hasn't seen much of during training can be a hurdle. True zero-shot tool use is still tough.
Makes sense.
And probably the biggest ongoing technical challenge is ensuring safety and reliability. Preventing unintended consequences when the agent interacts with complex systems or performs actions with real-world effects. That requires very careful design and testing.
Yeah, robust safety mechanisms are key. Okay, let's shift to performance benchmarks. The source includes a big comparison table Kimi K2 instruct versus models like DeepSeek v3, Qwen 3, Claude, GPT 4.1, Gemini. What's the main story from those numbers?
The headline seems to be that Kimi K2 Instruct performs very competitively. It either matches or, in quite a few cases, actually outperforms these other strong models, both open source and proprietary.
And where does it particularly stand out?
It seems to shine specifically on tasks that require deep knowledge and complex reasoning. Those benchmarks really test the model's understanding and ability to connect information.
Okay, let's get specific. What about coding performance?
The numbers look strong there. On SWE Bench verified tests, using Bash and editor tools, it achieved a 65.8% pass rate on the first attempt for fixing code.
Pass at 1. Right. That's pretty good for automated patching.
Yeah, and if they allow parallel computation during testing, that jumps to 71.6%. It also got 47.3% pass at 1 on the multilingual version of SWE Bench. Shows real capability in understanding and fixing code. Okay, solid on coding.
Right.
What about other technical areas like math or using those tools we discussed?
Tool use benchmarks like Tau2 and AceBench show solid performance, confirming that agentic training paid off. And for math and STEM tasks, the results are also quite robust. For instance, 49.5% average score across 64 attempts on the AIM 2025 math competition problems.
He is tough.
It is. And 97.4% accuracy on the Math 500 data set. These suggest strong reasoning and problem-solving skills in structured, formal domains, not just language fluency.
Right. So, wrapping up the benchmarks, what's the takeaway for you, our listener? The source really emphasizes Kimi K2 delivering excellent results across the board: language understanding, math, science, coding, and that agentic tool use. And it's apparently available free on their website with those MCP features rolling out, plus an API compatible with OpenAI and Anthropic standards. Seems they want people to use it.
Definitely pushing for adoption.
So, to recap today's deep dive, we looked at Kimi K2 focusing on the tech, the innovative MuonClip optimizer tackling training stability,
Yeah, that key clip technique is neat.
the large-scale agentic data synthesis approach, the general reinforcement learning with self-judging.
And the impressive benchmark results showing its capabilities.
It really feels like it's pushing the boundaries, moving beyond just language processing towards models that can genuinely act and learn more autonomously.
Absolutely. It's part of that shift towards more active, capable agents, not just passive responders. The whole era of experience idea is central to that.
It really is. The technical landscape is shifting fast. Models like Kimi K2 seem to be right at the forefront of making agents more independent, more capable, learning from their own experience. It really does change the game.
Which brings up a final thought, maybe something for you to ponder. As models increasingly learn from these self-generated interactions in this era of experience, what new technical challenges pop up? I mean, how do we truly understand, predict, or even control the behavior of a system that's primarily teaching itself? How do we guarantee reliability or prevent unexpected, maybe undesirable emergent behaviors when the learning process becomes so internal?
That's a deep question. Ensuring robustness and predictability when the model is its own teacher. Definitely something to think about. Thanks for joining us on this technical deep dive. Until next time, keep exploring those fascinating frontiers.